Hello and welcome to Fusion 360 Tutorials by Industech. My name is Lawrence and I'll be your instructor for this tutorial. Today we'll be exploring the design process using sheet metal tools in Fusion 360. In this lesson, we'll design a tissue holder with specific dimensions, focusing on the unique aspects of sheet metal design. By the end of this tutorial, you'll gain hands-on experience with basic techniques and be equipped to create complex sheet metal designs using Fusion 360. Let's get started. We'll start with a new component from the toolbar. When designing for a sheet metal, you have to select the component type as sheet metal component. After selecting a sheet metal, your file will not have sheet metal at the bottom of the dialog. Sheet metal rule describes the sheet metal characteristics and how the parts are being manufactured. For example, rules will dictate material thickness, bend radius, and corner relief. We'll discuss further on this in the course of this lesson. For now, we'll set these rules to the steel millimeters option. We'll name this material sheet metal design, though it's a napkin holder, before selecting OK. Now we click OK. All the sheet metal tools are organized in the sheet metal tab. Within the sheet metal tool, you find the flange tool, which is the most used of them all. It's normal for sheet metal design to start with a base flange because it represents starting with the start piece of a metal. Fusion sheet metal tools are parametric, just like the solid modeling tools. Many of our sheet metal parts will start with a profile sketch. For a base sheet, let's sketch a simple rectangle. Press letter R for the rectangle and select the bottom origin plane to sketch on. This design will be symmetrical, so let's select the center rectangle before going to the origin point. This will make it easy to constrain things and keep it symmetrical. Creating the base of the napkin holder with length 125 millimeters and width 60 millimeters. Okay, so we go back to the sheet metal tab. As we can see, we then activate the flange tool. The flange tool helps us turn sheet metal sketches into sheet metal faces. To create a sketch, select the sheet metal face. And notice it automatically applies the sheet metal thickness based on the steel rule we selected in creating the components. We will later discuss how we can change this rule. When necessary, you can also select the side of the flange, the plane, the profile, the flange, and the sketch sits on. Alright. Let's select OK. This result may look similar to a sketch with an extrude. Okay, but instead you realize in the browser in the body we have a sheet metal instead of a solid body. Let's now create the two other sides of the napkin holder. We select the flange tool. We select the two edges of the plane and we drag up the green arrow. This is one of the great benefits of the flange tool. We can quickly create edge flanges from existing flanges. Let's select the height to be 130 millimeters. Okay, let's try to make some adjustments. You realize that for each of the flanges we can select the edge type, full edge, symmetric, two side, depending if we want the sketch to run through the entire length. We can also select the angle, say 60 degrees. Let's see what happens. Alright, okay. We can always adjust the angles back to 90 degrees. And lastly, we'll set our height datum and bend position. Setting the height datum, choosing the outside face. That simply means that you want the length, the width of the shape to be measured from the shell, from the outside, from the base on the outside right onto the length. But when you choose inside,
You want Fusion to calculate the length from the inside, from the inner part of the shell to make the calculations for just both the height and the width.
Our bend position controls where the bend is positioned between our base flange and our new flanges. The new flanges are on both sides. If we want to retain the 60 millimeters dimension from the inside, length of the base from the inside, then we'll have to choose outer face. But if we want to retain that same 60 millimeters from the outside, measuring from the outer shell, then we'll have to choose inside. It will shrink or reduce the length from the inside and outside. We'll see that. So let's see the effect of these two different options. Let's press the home view. Let's choose the inner face and see the distance between the two opposite planes. Okay, we select OK. Let's see the distance between the two inner faces. So we select them. We can see that 55 millimeters. That is 5 meters reduction from the original length, 60 millimeters. Let's put it back to the outside diameter and see what happens. Okay, we'll just go back, set it back to the outside diameter. Let's now check the distance between the inner planes. That's done. Let's see. Okay, we can see that to be 60 millimeters, and that was the exact length we selected from the onset of the design. Now calculated from the inside, not outside. High datum can have significant impact on sheet metals that need precise measurements. We will now add round fillet to the top edges to create the rounded portion of the design. Okay, and the fillet option, we have types of fillet, but we go for the full round fillet. To retain the shape, even if the dimensions are changed later, we choose the full round fillet. We'll start by selecting the top center face. Then the edges. The effect. Selecting the edges, the effect is applied immediately, we can see. Repeat same procedure for the other side of the flange. Doing this, you can hold the command key and mark or control key in Windows to do the selection. Okay, almost true. Press OK. The basic shape of our napkin holder is now complete. Let's take a look. To finish up our design, we select the flange. No, the create flat pattern. The pop-up will ask us to select the stationary face. The stationary face is the base flange on which the other flanges are designed upon. So that's it. We select and we press OK. Yeah, we press OK. Once complete, you realize a two-dimensional sheet body appears, converted to a two-dimensional flat pattern, including our bend lines, bend zones, and center lines. When doing this, ensure you're in the flat pattern environment. And the flat pattern environment, you have tools specific to accomplishing these kind of tasks. Finish sketch. Features added in the flat pattern will not reflect in the folded model. Okay, our model is folded back to its formal shape. Then flat pattern is created on the browser. You can switch from the folded state to the flat pattern state using or activating the flat pattern on the browser. So let's finish our sketch by creating a slack down the middle, just where the arrow is on this face. We'll start here. We create a sketch here on the upper flange. Okay, we create a sketch. Okay, time to continue. Now we select our offset tool here. On the offset tool, make sure you uncheck the chain section so it can let us select the flanges top without selecting the bottom. We can actually check and uncheck, as you can see. This value can be small or large depending on how small you want the slot to be on the final design. Okay, then we can select OK. So furtherwards, we can use the line tool to offset or cut out the unwanted bottom section on the bottom flange. So we select the line tool, we mark it off on the both sides. The two selected portions can also be seen on the browser as Sketch 1 and Sketch 2. We can see that. We go ahead to use the extrude option to cut out these two selected portions out of our existing shape. Next, set the extend type as two objects before selecting the opposite side of the drawing, of the design rather. This will help our material to remain parametric when the overall thickness of the design changes. Okay, let's now look at changing our sheet metal rule. We can open the sheet metal rule to create an existing rule or create a custom rule. We won't select an existing rule now, but we'll be creating a new custom rule. We can see new rule. We click on that. Okay, I'm going to rename this to 2 millimeters steel. I want to rename that. Then change the thickness to 2 millimeters. Yeah, 2 millimeters. You realize that we have the K factor, bending conditions, and corner conditions. These will vary depending on the type of material, the type of bending, and other considerations. Okay, let's take a closer look on the features of the new rule we're about to create. The thickness, the K factor, the bend conditions, the corner conditions, and the rest. The thickness can always be changed to the intended thickness of your design. That is, as we began creating, we started with a particular thickness, but at this point we want to introduce a new thickness. So in the new rule on the thickness section, we put the exact thickness we want for our design. Okay. All right. So this is what we have. This is what we have. Okay. So we can now save. Each sheet metal component has a rule associated to it. We go to the browser, we can see rule. We select, then choose the new rule we just created. Press OK. If you've paid close attention, you'll notice that the thickness changed as we just clicked OK. The K factor and the bend radius would also affect the bend of the design. Yes, the bend radius. Also, you should note that changing the sheet metal rule can be done at any point, anytime in the design. However, you might choose to do it before or after your design. Okay, so let's change the appearance of the design. Final appearance. Color, material. Let's change, yes. So we right click, select appearance. I choose to go with paint metallic, silver. That's the end of our tutorial. Thank you so much and see you next time.